Hi, I'm Ravi.
I'm Ron.
And I'm Alex, and this is our E123 final project.
Oh my god.
Alright, so this is our setup. So we have our image on our computer here, and it gets AFSK modulated and packeted into AX25 packets, which is an amateur radio standard. Then that signal goes through this USB interface to this audio device. This audio device generates an analog audio signal, which gets sent through this ground isolation loop, and then that signal is then sent to our radio, where it is FM modulated and sent over the airwaves. Then on the other side, the receiving radio FM demodulates it, sends it back through the ground isolation loop to the audio device, and it is recorded and sent to the computer for AFSK demodulation. For our project, we implemented AFSK 2400, which is a form of digital modulation that converts our signal from ones and zeros to an analog signal. So AFSK means that we turn our bits into marks and spaces, and we key frequencies. 2400 means that we're sending 2400 bits per second.
One of the first steps in our image compression was to decide if the image was black and white, grayscale, or color. And to do that, we took the three different color channels, the RG and B channels of the image, and we found the mean squared error between the three different channels. If it fell below a certain threshold, we knew it was either grayscale or black and white, which allowed us to significantly decrease the amount of data we would send. And if it's color, then we would go ahead and use all three channels and apply the general compression techniques.
To select the compression we used to send the image, we cycled through all the types of compressions we could do, and then we selected the one that gave us the best pace scenario. We used DCT, DWT, and decimation to compare. To decimate, we ran a Gaussian low-pass filter on the image, and we downsampled. And to reconstruct, we upsampled and then ran another low-pass filter.
For our JPEG and DWT, discrete wavelet transform compression techniques, we took our image and split it up into 8x8 blocks, and we performed each of the transforms, either the discrete cosine transform or the discrete wavelet transform. That leaves us with an array or a matrix of coefficients, and according to the JPEG standard, we applied a quantization matrix, which would basically divide each coefficient in the matrix by a certain value. If for higher frequencies, the quantization matrix divides the coefficients by greater values and essentially brings them close to zero, which means that we can ignore them when we're sending them and during our compression step. So once we have just a few coefficients remaining in our matrix, we arrange the matrix in a certain way that will group all the zeros together and group all the coefficients together, and we can run a run length encoding on it. And following that, we just pass it through our modulation and receive it on the other side of our setup.